Hi guys, it's Mrs. McGovney, and I just wanted to show you something really fast to kind of bring everything together. I'm not sure if you're able to see everything that I have inside of this biome, but I have a plant that I tore and I put in there. And so let's pretend that it's still in the soil and it's still growing. So if you can tell, the sunlight is hitting my face, and that same sunlight is also going through this clear, transparent bowl. And so the light is able to be transmitted through it and to the plants inside of it. Also, the green is the color that's being reflected. However, it's the chlorophyll within the cells of the plant that gives it that green appearance to it. And because of the chlorophyll inside of the chloroplasts, that is how the plant is able to take that sunlight through the process of photosynthesis and convert it into a chemical energy in the bonds of the glucose, that C6H12O6. All right. And so not only do we have the plant able to use this solar energy and transform it into a potential chemical energy that will, through the process of respiration, release it as energy for the plant to use, ATP, adenosine triphosphate. However, inside of this bowl, you have the thermal energy that has been transmitted through the bowl, and the green in here is absorbing your blues and your red lights. And so there is energy that's being absorbed here. And so as it warms up, the grass or the plant itself is warming up, and also the air molecules that it comes into contact with through conduction. This is radiation, and this is conduction whenever your molecules are physically hitting the ground and the grass. And then those molecules warm up. Once they warm up, they're going to expand, become less dense, and they're going to rise. And this is convection. And they'll cool off because they're still conducting energy to other molecules they bump into. And so then they're going to sink, become higher, more dense, and they're going to sink. They're going to hit the ground again. They're going to expand. They're going to rise. They're going to constrict because they have now given off energy to other molecules, and this is the convection current. So we have radiation, we have conduction, and we have convection all occurring within this. However, I also want to talk about the matter itself, because the types of matter and what it's like is what dictates whether or not solar energy can even get through. If you notice, this bowl is pretty transparent. However, and so you're able to see through it. However, if you notice on this other side, it's kind of frosted. There are particles which prevent you to be able to see it. It's more translucent, and so you're going to have more scattering. So you can still see through it, but not completely accurate. And so this side of the bowl should be more clear. You should be able to see better than this side over here. That's because this side of the bowl is transparent, whereas this side is translucent. So some light is able to get through, but because of the scattering, you can't see everything clearly through it. Also, you have opaque materials, and that tends to absorb and reflect the sunlight back. And so if you notice, I'm sitting under an umbrella, and if I were to change this umbrella, that would prevent the sunlight from hitting me quite as much. If you notice, one side of my face is shaded and the other is not, and I'm not doing a very good job of blocking the sun with it, but that's okay. I've got something else blocking it. But this umbrella, because it is opaque, it is preventing the sun from shining through. You have a little bit of it that you can see coming through, but not much, and that's just because of the spaces in the material, and it's still transparent there. And so that's another thing to think about. Whenever you have opaque objects, you're not going to have the permeation of that energy. You're not going to be able to have all that transmission of the energy as you would with your translucent and transparent materials. Also, another thing, I don't have it right out, because if you were to put a pencil in water, for example, it would look like it takes on, like it moves, like it's bent. But that's actually caused by the liquid, and so it causes the electromagnetic waves to slow down and change. And it happens here from the air to the solid as well, except you can't really see it. Let me see if I can manipulate this a little bit so you can see it. Not really. But what you guys can do as you're figuring out, yeah, you can see it a little bit. Okay, let me see. Can you see how that little piece, that blade, has what appears to be a bend? That is also caused by refraction. I'm not sure if you were able to see that or not. Usually I do this with my computer, but I'm on my phone today. But because this material is different, the solid, the molecules are closer together than the air molecules, it causes that solar energy, the magnetic waves, to actually change direction, and it speeds it down a little bit. So this is how we get reflections and refractions and transmission of light. Your reflection is usually from your opaque materials, and if they're smooth and they tend to be shiny, we'll have light bouncing back off. And it all depends on the matter, what type of matter it is, the surface of the matter, the color of the matter, and the texture. If you guys have any questions, let me know. It's good to see you. I hope to see you in person. Goodbye.